Hello and welcome to the part number 23 of the Node Editor tutorial series. My name is Pavel Krpla from BlenderFreak.com, and in this part we are going to finish the Ctrl-C and Ctrl-V operations. As you can see, they are working great. Ctrl-X, we can undo, we can redo, and our whole application still works. Which is awesome. So let's start coding. Okay, so let's start implementing the serialization when we press Ctrl-C to the clipboard. So basically we will start somewhere here. So if debug, then print, copy to clipboard. Okay, Ctrl-C, copy to clipboard, works awesome. So first off, let's get the list of all selected items. So self equal to self.scene.graphicalScene.selected items, and then we are going to create a list. And then we are going to create lists for nodes, edges, and maybe a hash map or dictionary for sockets. So selected nodes, selected edges, and selected sockets will be equal to empty list, and empty dictionary. Now we are going to sort edges and nodes. Then we can basically print out some debugging information. So let's write that down. So if debug, then we are going to print nodes, free, and selected nodes. Then we are going to print out the edges, selected edges, and we can print out the sockets. Print sockets. Okay, then we are going to remove all edges which are not connected to a node in our list, because we don't want to store the edges leading to nowhere. And after that we can create the data which we will actually store, and the data will be ordered dictionary. So let's go ahead and import that from collections, import ordered dictionary, and you can use this delete, because when we do cut, we want to delete the selected items. So if cut aka delete, remove selected items. So that's gonna be if delete. Then we are going to call self scene graphical scene. I guess we need to go up to the view and delete selected, and we can return the data. So let's try that. If I did some typo, I did not, which is great. So let's start sorting. First off, we will go through each of the selected items. So for item in selection, and we can basically write a little bit less code like this, and if it has attribute item as attribute node, then we definitely know that it's gonna be node. So selected nodes dot append item dot node dot serialize, and I made a typo. And for each node we wanna have a list of the sockets. So for socket in item.node.inputs plus item.node.outputs, we are going to say cell sockets. The key is gonna be the socket.id, and we will store the reference to the socket. Else if is instance, the item is instance of QDM graphics edge, then we are going to store that to the edges. So selected edges dot append item dot edge, and we need to again import the graphical edge. So from node graphics edge import QDM graphics edge. So this way we are going to sort out the edges and nodes. So let's test it again. We got order dictionary with something, and there is one edge, second edge, one node, and probably there should be another node, second one, and here is oh, these are sockets, so here is one node and one edge. What are we going to do next? We need to remove all the edges which are not connected to a node in our list. So that means we can mark the edges to remove. And for each edge in selected edges, we will check out if edge.start socket.id is in selected sockets. This way we are going to check if in this dictionary is this key is present, and the edge.endsocket.id is in selected sockets. So if this is happening, we can print edge is okay, connected with both sides. Or maybe we can just pass, and we can print out if debug print edge is not present. And which edge? Maybe we can say self, not self, but just edge is not present, or it is present but is not connected, with both sides, and therefore we need to remove it. So edges to remove, append edge. And once we finish this, we can go for each edge in edges to remove, and we can call selected edges dot remove current edge. So make final list of edges, and edges final is equal to empty list, and for edge in selected edges, final dot append, and we will pass edge dot serialize. Awesome. That means we will construct our old dictionary with nodes. That's gonna be selected nodes, and with edges, that's gonna be edges underscore final. And this should basically work. So let's test it. I will select 2 nodes and 2 edges, and I will press Ctrl C, and you can see we got one edge which is not connected with both sides. Therefore we should see, okay, we don't see because we didn't print out data itself. So let's have a look where we actually are using the Ctrl C. That's gonna be here in the node editor window, and on copy, we can for now print the string data. So let's try that again. Ctrl C. I can close it now, and I will scale it a little bit. We got one edge, which is here, and my awesome node 2 and my awesome node 1. So this should be correct, if I'm not mistaken. Okay, so let's go here and let's think about the deserialization. Basically that's gonna be almost the same as the scene deserialization, so we actually need a hash map or dictionary. Then we are going to calculate the mouse pointer is scene position, because we wanna paste the things or the items into the center of the mouse we are currently pointing in. So we will calculate selected objects, bounding box, and its center. Then we will calculate the offset of the newly creating nodes, and we don't need to change the position of the edges because they are connected automatically to the node itself. Basically then we will go through each node and we will create each node. Then we will basically go through each edge and create each edge, just like that. And at the end we will store history for our undo and redo. So we should do that here too. If there's gonna be delete, we need to store our history also. And to store our history we will basically call self.scene.history.store history, and that's gonna be named cut out elements from scene. And let's start have a look at the deserialization. So mouse pointer and the position. First off, let's fetch a view of the scene, so self.scene.graphicalScene.views, and the first view. Mouse scene position is then gonna be view.last scene mouse position, and let me check if we actually did implement it. We should have, but I will rather check it than have a crash. Last scene mouse position, yes, exactly, and that's basically what we are printing out anyways. So scene history, scene clipboard, that's here. So let us continue. Let's calculate the bounding box. So minimum x and maximum x and minimum y and maximum y are going to be 0, 0, 0, 0. And for each node data in data nodes, we can basically go through and say x and y is equal to node data position underscore x and node data position underscore y, and then we will simply check if x is less than minus minimum x, then minimum x is gonna be x, and the same condition goes the other way around. So if x is bigger than maximum x, then maximum x is gonna be x. The same for y. Minimum y is equal to y, and if y is bigger than maximum y, then maximum y is gonna be y. Nice. This one should find the minimum and maximum x and y. So bbox center underscore x is gonna be minimum x plus maximum x, and this is gonna be divided by 2, and the same goes for y, minimum y and maximum y. So the center is going to be at position view dot map to scene view dot rectangle center. That is the current point of the middle of the window we are looking at, and therefore we can calculate the offset. So offset x is equal to mouse scene position dot x minus bbox underscore center x. Or maybe, do we actually need the center? No, we don't. So let's comment it out. Offset y equals to mouse scene position dot y minus bbox underscore center underscore y. Okay, so now we will create each node. So for node underscore data in data nodes, we will create a new node. So new underscore node equals to node in self.scene. That's the reference to the scene we need to pass, and we don't know the node, so from node underscore node import node. This is correct, and from node underscore edge we are going to import edge, or maybe everything, or maybe just edge and edge type Bezier, or maybe not, just edge for now. So we will get our node. First off, we are going to say that new node dot deserialize with the node data and hash map, and we are not going to restore the ID because we are actually pasting, or we could be pasting from the copy operation and not the cut operation, so therefore we need a new ID for the node. So we will keep a new ID there. Then we will readjust the position of the newly created node. So position equals to new node dot pos, and new node. So let me write the comment here. Readjust the new node's position. New node set position, and here is gonna be the position x plus offset x and position dot y plus offset underscore y. And this should center the nodes for us. So let's test if we made some mistakes. I will copy these and I'm gonna paste it here. And as you can see, they are almost perfectly in the center of the mouse cursor, which is awesome. Let me check that out. What do we got here? A lot of nodes, and maybe now if I select everything, and I'm not able to select everything because there is a bug, but anyways, we could save it to the file and check out the node IDs, but they should be correct. So let me go ahead and fix that nasty bug. And the bug should be in the node graphic view here. When we got middle mouse button press and release, we are faking an event, and then when we release the middle mouse button, we are setting the drag mode to no drag. And this is not correct because we do not want to disable the dragging. We are going to use rubber band drag to reset the rectangle selection. So now when I move with the middle mouse button, I can still select these items. So let me copy that a few times. Select everything. Is it selected? Yes, it is. And when I press Ctrl C, we get this awesome stuff. And nobody can read in one single line. So basically, let's close that for now. And let's try the edges, because since we don't restore the ID, also the sockets shouldn't be restored. So if this doesn't work, we will not be able to connect the edges. So if actually there are any edges in the data, because we could just copy one single node without any edge. So first off, let's check if there is edges in the data at all. And I'm saying almost nonsenses because we will always have edges here. But anyways, doesn't matter. For edge data in data edges, we are going to create the new edge. So the new edge equals to edge in self.scene. Then we can just deserialize the edge and it should work. So new edge equals or dot deserialize and pass in the edge data, the hash map, and restore ID will be equal to false again, because we do not want to replace the IDs in the inside of the edges. And once we do that, we can just store the history, and that can be done with self.scene.history.store history. Pasted elements in scene. So let's test it out. I will select 2 nodes and 2 edges, Ctrl V, and we got new edge and new node. This is still being connected. This one is still being connected too. We got a debug here, which says that the socket is value of 5F8, and this one got it the same, but it's 309 and not 30A. So this basically looks like it works. This edge got 309.748, and the upper one got 30A and 518. So this one actually works. Do we have the right mouse button click on the node? No, we don't have one. So we can Ctrl C this one and check out that the node here got ID 4752. Okay, so let's remember 4328. So let's select the upper one and press Ctrl C and check out this one, and as you can see, the ID is different. So when we save this in a file, there should be no errors at all. So let's try that. Save it as graph2 JSON.txt. I will clear that up and open the file I just saved, and you can see we got one node, second node with edge connected, and this worked too. Awesome. So this looks like it works. I'm going to delete the graph and disable the debug. So Ctrl C, Ctrl V, and if I press Ctrl Z, I can restore the operations and use fully functional undo and redo. Awesome. So this one works, and we just finished the Ctrl C and Ctrl V logic in our node editor. So thank you for watching, and see you at the next part.